Okay, well, in question number 13, we have to integrate e to the power of x upon 1 plus e to the power of x into 2 plus e to the power of x. Okay, so straight away I'm going to substitute e to the power of x is equal to t. On differentiating, I'm going to get e to the power of x dx is equal to dt. Okay, so this becomes 1 plus t into 2 plus t. Okay, so on substitution, integral which was given to us as e to the power of x and so on has become dt upon 1 plus t into 2 plus t. Now what I'm going to do, I'm going to convert 1 plus t, 1 upon 1 plus t into 2 plus t into its partial fraction. So its partial fraction will be equal to a upon 1 plus t plus b upon 2 plus t. Okay. So on cross multiplication of this whole term, I'm going to get 1 is equal to a into 2 plus t plus b into 1 plus t. I'll mark this as equation number 1. In equation number 1, what I'm going to do, I'm going to place 1 plus t is equal to 0. This gives t is equal to minus 1. On substituting t is equal to minus 1 in equation number 1, I'm going to get a is equal to 1. Okay, because 1 plus t is going to become 0. Similarly, to calculate the value of b, I'm going to place 2 plus t. 2 plus t is equal to 0. So this gives me t is equal to minus 2. Okay. On substituting t is equal to minus 2, this term a into 2 plus t will become 0 and this is going to become minus 1. So I'm going to get 1 is equal to minus b or b is equal to minus 1. Okay, so instead of this integral or this term, I'm going to integrate 1 upon 1 plus t minus 1 upon 2 plus t. Okay, so our given integral is converted into this form, 1 upon 1 plus t minus 1 upon 2 plus t dt. Okay, now this integration is very simple. Integration of 1 upon 1 plus t, this will be equal to log of 1 plus t. Integration of 1 upon 2 plus t is equal to log of 2 plus t plus c is always going to be there as an integral constant. Now to obtain the final answer, I'm going to place t as equal to e to the power of x. So I'm going to get log of 1 plus e to the power of x minus log of 2 plus e to the power of x minus log of 2 plus e to the power of x plus c, applying the formula of log of m minus log of n is equal to log of m upon n. I get this as log of 1 plus e to the power of x upon 2 plus e to the power of x plus c, the required answer. Okay. In question number 14, to integrate 1 upon x square plus 1 into x square plus 4. First of all, what I see here, that this term 1 upon x square plus 1 into x square plus 4, which we have to integrate, contains no terms other than x square. Okay, so if an integral is like this, that it is containing no terms other than x square, then this can be simplified into partial fractions by placing x square is equal to y. Okay, so on doing this, I'm going to get this as 1 upon y plus 1 into y plus 4. Okay, had we have not taken y, x square is equal to y, then its partial fraction would have been ax plus b upon x square plus 1 plus cx plus d upon x square plus 1, and here the partial fraction would be a upon y plus 1 plus b upon y plus 4. Okay, now you can see that here the process have been much more elaborate than in this case. Okay, so I have done this in this manner. Okay, the answers are going to come the same in both the cases. Okay, but the logic here is this, that this fraction contains the terms only of x square. Only in this condition this can be applied, so that some unwanted results are not obtained. Okay, so on cross multiplication of this, I am going to get 1 is equal to a into y plus 4 plus b into y plus 1. Mark this as equation number 1. Okay, on placing y plus 1 is equal to 0 or y is equal to minus 1, I am going to get a is equal to 1 by 3. Okay, and on placing y plus 4 as equal to 0, I am going to obtain y is equal to minus 4. On substituting this value in equation number 1, I am going to get b as equal to minus 1 upon 3. Okay, so the integral now is equal to 1 up. So the fraction is equal to y minus 1 into y plus 4 is equal to 1 upon 3 times y plus 1 minus 1 upon 3 times y plus 4. But actually y was equal to x square, so I am going to place x square plus 1 into x square plus 4 is equal to 1 upon 3 x square plus 1 minus 1 upon 3 x square plus 4. Okay, here one thing should be kept in mind. We have not done any substitution related to integration. We have just replaced the value. Okay, so the value of the required integral 1 upon x square plus 1 into x square plus 4 is equal to integration of 1 upon 3 x square plus 1 minus 1 upon 3 into x square plus 4. Okay, dx. Now integration of 1 upon x square plus 1, this is directly equal to tan inverse of x minus 1 upon 3 remains as it is. Integration of x square plus 4 is equal is done in the same manner by integrating 1 upon x square plus 2 square. This will be equal to 1 upon 3 into 2 into tan inverse of x upon 2 plus c. So our final answer would be 1 upon 3 tan inverse of x minus 1 upon 6 tan inverse of x upon 2 plus c, which is our required answer. Okay.